This is chapter 1, chapter review. We are on page 60 reviewing all of chapter 1. So we started off in chapter 1 looking at order of operations. And so we are going to start there. Pretty basic one to start with here, both division. You're just going to go left to right. So 20 divided by 5 is 4. And 4 divided by 5 gets you a nice decimal of 0.8. When we don't get a nice decimal, we're going to leave it as a fraction. So this is the same as 4 divided by 5, or 4/5. All right, number 2 now. 70 minus 4 times negative 3 divided by 2. So we have to follow PEMDAS, parentheses first. While I have parentheses here, there's nothing to complete inside of it. So nothing to do there. Exponents, don't see any. So now I'm multiplying and dividing from left to right. So I see multiplication and dividing. I also want to consider the fact that since I see subtraction here, that's the last thing I'm going to do. So I'm going to leave that alone. So I'm going to multiply. 4 times negative 3 is negative 12. If you wanted to do the division right away, you could think about it, but I like to spread it out so you can see everything. Now, the 70 and the minus is going to stay. Negative 12 divided by 2 is negative 6. Saving subtraction for last. Minus a negative is like adding a positive. This goes plus plus. And our answer is 76. Number 3. 5 times 0.43 raised to the second over 0.43. So when we have one of these problems where it's a fraction and there's things to do in terms of operations, we've got exponents, multiplication in the numerator, in the denominator, we have to take care of all of that first. It's kind of like it's in parentheses. The last thing we're going to do is take whatever's on the top and divide it by whatever's on the bottom. So step 1 would be to go ahead and square 0.43. So 0.43 raised to the second. And so I have 5 times 0.1849 over 0.43. Now I can go ahead and multiply. So 5 times that number, 0.9245 divided by 0.43. And when I run the numbers, I get 2.15. Okay, number 4, some fractions. Let's let the calculator handle it. 3/8 plus 5/6 times 4 plus 3/5. Now, I've got parentheses here with an operation on the inside. So that's the first thing I need to do. So if you didn't have a calculator available, you'd have to get common denominators, change the numerators, on and on and on. But we are using the calculator. If we're using a graphing calculator, these specific ones, the shortcut is the alpha button, the green alpha button, and then the X button next to it. That will bring up your fraction. So 3/8 plus 5/6. That's 29 over 24. So completing the parentheses first, I now have multiplication and I have addition. So I'm going to multiply first. So I've already got this number in my calculator. I'm just going to hit times 4. I get 29 over 6. And all I need to do now is add my 3/5. So I'm going to hit plus, bring up my fraction, 3/5. And I get 163 over 30. And you can leave that as a final answer. You can also divide 163 divided by 30 and turn it to a decimal, which is 5.43 repeated. But leaving it as a fraction is perfectly fine as well. And on your quiz, you're not going to have to make that distinction. Nothing's going to leave you in a spot where you have to try and figure out what I'm looking for in terms of fractions and decimals. Not going to see any of that, so no worries there. Just good practice right now. Okay, number 5. So now kind of following the same order of operations, but with algebraic expressions, so variables that we have to plug into. So we have 4x squared, x equals 13. So we are going to plug this in for x. X is 13, so it's 4 times 13 squared. So we need to make sure that we don't multiply and then raise it to an exponent. Exponents first. So 13 times 13 is 169. So this is going to be 4 times 169. Go ahead and run that, and you get 676. I'm going to bring the 6 up here. So negative 6q minus q, and q is going to be negative 3.64. So it's negative 6 times, you can write that however you want, negative 3.64 minus negative 3.64. So minus a negative, this will go plus plus. And when I multiply two negatives, this will be positive. So this will be a positive plus a positive. So 6 times 3.64 is 21.84. And again, a negative times a negative is a positive. And you're minusing a negative, which is the same as adding a positive. So when I put those together, I get 25.48. Okay, number 7. So I've got this algebraic expression, I've got fractions. I'm going to have to divide both of those before I add. The last thing I'm going to do is add. So I'm going to complete the top here and divide. I'm going to divide here, and then I'm going to add. Now, if they're not nice division problems, we'll just leave them as fractions and combine the fractions. So x is 7. So I have negative 5 times 7 over 2 plus 3 over negative, and now you plug in 7 for x. So I'm going to get negative 35 over 2. Does not divide perfectly, although it would be a decent decimal. Plus 3 over negative 7. Now, if you tried to divide 3 over 7, that's not a nice decimal, so we don't really want to do that. So let's leave this as fractions and just let our calculator do the work. Again, nothing crazy with fractions on the test, so not something to worry about. So I'll put the negative out front. 35 over 2 plus negative, and if instead of plus a negative, if you just want to write minus, that's fine. 3 over 7, and final answer here, negative 251 over 14, and if you wanted to turn that to a decimal, you would divide. So 251 divided by 14, and you get this decimal. Not a very pretty decimal, but if you were looking for a rounded decimal answer, you would take this 17.9, 17.93, something like that. All right, one more from this section. We have n over 3 raised to the third, and we're plugging in 24. So first, let's plug it in. And before we worry about that exponent, we do have parentheses, and this is an operation. Right? This is division. So 24 divided by 3 is going to happen first because it's inside parentheses. That whole thing is going to get raised to the third. Now, we'll talk about exponent properties where we can actually bring this into both, and that's fine. But in this case right now, following the order of operations, all we need to do is divide first and then raise it to the exponent. So 24 divided by 3 is 8. And then 8 to the third, 8 times 8 times 8. And you can do it in your calculator. So you're going to use the raise to button, 8 to the third, and it's 512. Okay, number 11, we talked about instances for a pattern. We're going to describe this pattern using one variable. So you're going to look at the three instances that are given. Each one is going to have a different number or numbers plugged in to where the variable would be, but there's also going to be things that you see that are consistent, and so those are actually part of the patterns, like the 4. I see a 4 times something to start every single one of these, so that's part of my pattern. 3 times, I see that, equals 7 times something, I see that. So those are all parts of my pattern. What's changing is I have a 2 in these 3 spots, I have a negative 3.1 in these 3 spots, I have a 2/5 in these 3 spots. So those are the numbers that are being plugged into the variable. So every time you see one of these new numbers, that's your x, or whatever variable you choose. So the 4 is there every time, times something different, so x, plus 3 times that same number. So if this was a different number being plugged in every single time, then you have to use a different variable. But the 2 gets put in all 3 spots. So it's the same variable. So we called it x. And it's going to look like that. Okay, 13, looking at a sequence. So we want to figure out what this is going up by. Take a look at what the next term would be, and then how do we write an expression for the nth term? So we could predict how many dots are in a term way down the line without having to draw it out, or make a continuous table all the way out to a really big number. So first of all, I went from 1 to 5. So that means I'm going up by 4. So this should have 9, and you should always double check it. So I go across, that's 5, 6, 7, 8, 9. Okay, so that's 9. And while we're at it, I'm going to go ahead and start making a chart, because that's the easiest way to come up with an expression, is to just start with your chart. So I'm going to compare my terms to my dots. So 1, 2, 3, 4. I had 1 dot here, 5 here, 9 here. So if this is going up by 4 consistently, plus 4 every single time, then I know that this one should be a 13. So double check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, perfect. So how many dots will be in the 7th term? We're going to continue this chart out. We haven't written the expression yet to plug in, so let's just continue this out. 5, 6, 7th term. So we're going up by 4s. So 17 plus 4, 21, plus 4, 25. So for letter A, we don't necessarily need the expression at this point. We know there's going to be 25 dots. Easy enough to just add 4 a couple times. In words, describe a method to find the number of dots in the nth term. So I don't actually like that that is letter B, because to me, I'd rather already have letter C done in order to find that out. Kind of just a little backwards thinking. So we've already talked about how do we figure out this expression. Whatever it's going up by, the rate of change, that, so let me go ahead and just start writing C out. That is going to be what's attached to N. Now on that first quiz, a lot of you chose this as your final answer. So we need to be able to understand that this is not done, because if I start plugging these term numbers in, I'm not going to get the right answer. For instance, if I do 4, pick any random one, times 3, because I'm plugging it in for 4n, I need to get a 9. Well, 4 times 3 is 12. I didn't get the 9. What if I plugged in the 4? That's 16, but I'm supposed to get a 13. So 4n is not my final expression, because it's not producing the correct number of dots. But it is the starting point. It's going up by 4. So this is my rate of change. So just look at these two. 4 times 3 is 12. It's supposed to be a 9. 4 times 4 is 16. It's supposed to be a 13. You could do more, and they're all going to look the same. The 12 was 3 too high. The 16 was 3 too high for the number of dots. So I need to take this number and minus 3 to get to where I need to go. So let's do one more. So I have 4n. Let's say I plug in 2. 4 times 2 is 8, but I need a 5. So I need to do a minus 5. I need to do, not minus 5, minus 3 to get to 5. I need to do 12 minus 3 to get to 9. I need to do 16 minus 3 to get to 13. So I'm multiplying by n with the 4, and then I'm minusing 3, so I need this minus 3. All right, and then you could describe it in words. You're going to multiply n by 4 and then subtract 3. So whatever it's increasing by consistently, that's what you're multiplying n by, and then there's almost always going to be an adjustment that needs to be made to get you to the right number of dots. In this case, we were coming out 3 too high every single time, so we minus 3. If we were coming out 3 too low, then we would add 3. So we just have to make the adjustment based on what we see happening here consistently. All right, we have 16 to 21 and 24 left. So 16 to 21 and 24. So we're going to go ahead and fill in these tables, and we're comparing these two. So they look similar, but the absolute value is spaced out differently. So will that produce an equivalent expression? Will we get the same answers? So starting with this one, they want us to plug in -3, -2, 0, 4, and 5. Let's start with some positives, keep it easy. Plug in 5. 3 times 5 is 15, plus 5 is 20. Absolute value keeps it positive, and it's just 20. 4 times 3 is 12, plus 5 is 17. Absolute value keeps it positive. 0 times 3, 0, plus 5 is 5, keeps it positive. -2 now, so 3 times -2, that would be -6. And then 5 plus -6 is going to be -1, and that will be a positive 1 after the absolute value. And then I plug in -3. 3 times -3 is going to be -9, plus the 5 is -4. And the absolute value makes it positive. Oops, almost messed up there, getting ahead. All right, we're going to complete the next chart and basically just compare and see if we get the same answers. My guess is no. So here we're going to do 5 times -3. I get -15, but the absolute value will make it positive 15, plus 5 is 20. So far it's the same. Plug in 4. 4 times -3 is -12, but this makes it positive 12 plus 5, 17. So for positive numbers, it's the same. What about 0? Plug in 0. Anything times 0 is 0, plus 5 is 5. So 0 also holds true. So if something is going to go wrong here, it's going to be with our negatives. So when I plug this in, I'm multiplying negative times a negative, and I'm going to get a positive. So -3 times -2 is positive 6, plus 5 is 11. So right away I can see that's different, but let me go test this one, make sure this is also different, and I didn't just make an error here. So -3 times -3, that's positive 9, plus 5 is 14. So we had a 1 and a 4 and a 14 and 11, so these are not equivalent. Okay, 17. Working with our absolute value. So we've got -3 inside of absolute value, which will become positive. And 5 minus 3. Anytime you have an operation inside of the absolute value, you complete the operation until you're down to a single number, and then you can find the absolute value. So inside here, absolute value of -3 becomes positive 3. And then 5 minus 3, that's going to be 2, and the absolute value of 2 is 2. And so 3 plus 2 is just 5. $18. 9 times -2 inside absolute value. And then -9 times 2 inside absolute value. So one big mistake that we talked about when we were going through this section is people want to just get rid of every negative when they see the absolute value, but you have to complete whatever's on the inside first. So then you can take the absolute value. So 9 times negative 2 is negative 18. We're going to take the absolute value of that, which is positive 18. Over here, negative 9 times 2 is also negative 18. And inside the absolute value, that makes it a positive 18. Add those together, and our answer is just 36. Okay, 19, still working with absolute value, but now with an expression, so plugging in x minus 3 times x, for x equals negative 2. So first plug in the negative 2. So negative 2 minus 3 inside here times negative 2. So before we even move forward, look at this. This will become a positive no matter what this answer is on the inside, times a negative. So our answer will be a negative number. Negative 2 minus 3 is negative 5. And the absolute value of negative 5 is positive 5. So treat these like a grouping symbol, like a parenthesis. Complete everything on the inside there before you complete any operations on the outside. So 5 times negative 2 then is just negative 10. Okay, and 20. Plugging in negative 1 here. So inside the absolute value, I have negative 1 minus, inside this little absolute value, negative 1. So working on the innermost first. So I'm going to keep this outer absolute value still there. I'm going to leave the negative 1 minus alone. Absolute value of negative 1 is positive 1. So I still need to complete all of this. Don't just make these positives. Negative 1 minus 1 is negative 2. Now I'll take the absolute value of negative 2, and that is positive 2. Okay, and 21. Absolute value of x minus absolute value of 2x plus 1. And this whole thing is absolute value. So we're plugging in negative 3. So negative 3 inside there, that'll become a positive. 2 times negative 3, however you want to write that, plus 1. So here, I'm going to leave the big absolute value alone for now. This becomes a positive 3. Let's complete everything on the inside here. 2 times negative 3 is negative 6, plus 1 is negative 5. So I'm going to get negative 5 in here. That's going to become a positive because of the absolute value, so it's going to be 3 minus 5. Well, that's negative 2. Notice that I just keep bringing down the overall absolute value on the outside. Until you have a single number here, you're not doing anything with it. So absolute value now of negative 2 is positive 2. All right. And I'm going to get a new page here for number 24. We're going to do a mean absolute deviation. So these take a little bit of time. First, we're going to do the range, though. Range is the difference between your smallest number and your largest number. So when we look specifically at number 24, these are test scores. Lowest test score appears to be 72. And let's see, 97 looks like it is the biggest one here. So we have 97 minus 72. And so yeah, that's 25. So the range is just telling you how far apart are your biggest and smallest numbers. What's the range? Now, mean absolute deviation. First thing we need to do is go ahead and find out what is the mean itself. So you're going to add up all the scores and you're going to divide by how many you got. So I'm going to show my work. You don't necessarily have to do this. You can just plug it all in. I want you to see it. So 87 plus 94 plus 90 plus 73 plus 84 plus 83 plus 97 plus 72. Again, you don't have to write that all out. Just showing you the process. And that gets divided by however many you've got. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm dividing this by 8. Add all those up in your calculator. 13, we get 680. So 680 divided by 8 equals 85. Now this is the mean. That's just his average. That's his test average. So combining all his scores into one concise number, averaging them out, that's the mean, it's 85. Now mean absolute deviation, you could have two students that both have an 85 test average, but one who always shoots right around 85 and one who shoots really high, really low, and then in the middle is his test average of 85. Mean absolute deviation will give you a number to tell the difference between the two. So what we're going to do is we're going to find out how far off each one of these scores was from the 85. So you're basically just subtracting every single one. So 87 minus 85, 94 minus 85, and you don't have to write it out like this. I want you to see it. 90 minus 85. So let's say you were just doing this. You don't have to write 87 minus 85. You could just write 2. And then 94 minus 85. You can just write 9. 90 minus 85, you could just write 5. So there's shortcuts here. You don't have to write it all out like this, but I want you to see what I'm doing, so I'm going to write it out. 73 minus 85. Now you get a negative, but we talked about we're not taking negatives here. We want to know the distance away. So distance is measured as a positive number. We're going to average all these out. So if we have negatives, when we add them up, we're going to get the wrong answer. So we just want to know, on average, how far away were they from their average? So just taking positives. So 84, now I'm right here, minus 85. So how far apart are those two scores? Just 1. Then he got an 83. So he was 2 off of his average. 97, way off his average, 12 higher. And then 72, way lower, 13. So now you're going to go ahead and add all of these up, just like we did up here, and then divide by how many you got. Now this should always be the same number you're dividing by, so make sure you count 1, 2, 3, 4, 5, 6, 7, 8. If that number was different, then you missed something. Okay, it's always going to be the same number because you're taking each one of these to create a new number. So I'm going to add them all up. 2 plus 9 plus 5 plus 12 plus 1 plus 2 plus 12 plus 13. And divide by 8. Again, you don't have to go through that whole process of writing it out. You can just go ahead and add it up. When you get that, you should get 56 on top. And when I divide that, I get a mean absolute deviation of 7. So if I was comparing this guy's 85 to somebody else with the 85 test average and trying to figure out, well, who's actually more consistent? They both have an 85 test average, but who's more consistent? I would compare their mean absolute deviation. In this case, if he was a 7 and let's say the other one was a 2, well, the 2 is going to be more consistent because on average, they're always 2 away from their test score. On average, this guy, they didn't give a name, but this guy is on average 7 away from his test average. So he's 7 above it, 7 below it, and that's on average. Sometimes he's going to be close, sometimes he's going to be more, but on average, he's 7 away from his average. So that is kind of an inconsistent test taker there, and you can see it based on the scores. We had 2 in the 70s, we had some high 90s, we had some 80s. That's inconsistent, and that's why this mean absolute deviation number is so high.